Hello and welcome to our video or lesson. Topic 1, but part B. So we're still talking about displaying our information, and in topic 1A, we acquired that knowledge and understanding where we made a frequency table, a histogram, a bar graph, and so on. In topic 1B, we are going to do battle the calculations. And the first one is doing it by hand. So topic 1B, I remind you, will come in three parts as well, because there are different levels of calculations depending on my knowledge and understanding and the tools that I have. The very first one that I don't want to skip is doing it by hand, just solidifying that understanding. Then we can make that more efficient with a spreadsheet, and lastly, super efficient with a dedicated statistics software application. So we'll demonstrate all three of those uh, every time where it is appropriate. So this one is doing an example by hand. The question that I want to do comes from the Statistics for Psychology book, and it is number 14. It's a little pixelated on my screen, but hopefully on yours it looks okay. I want to do number 14 here. A social psychologist asked 15 college students how many times they fell in love before they were 11 years old. The numbers of times were as follows. So see, we don't have a lot because we're doing it by hand. So we'll scale the question appropriately depending on which type of calculation we'll do. We want to do the standard things that we saw in topic 1A, make a frequency table, draw a histogram. It's just the graphical version of that frequency table. And then we'll see, can we describe, can we say in words a little bit about the shape of the distribution we see? Sometimes we can, sometimes it's obvious, sometimes we can't, right? It's just a description. So let's get our frequency table. So I want to be aware, so this will be 15, and we're only going to do in the spreadsheet version. We'll do another one, so we'll have some variety throughout. I want to be aware of my variable in question. I'll call it x, which is sort of the standard letter to use for the variable. Say let x represent the number of times a college, was it college student? You know my memories. College students before they were 11. Okay. College student fell in love before age 11. So my variable is some properties, some characteristic of college students, in this case, a college student. Let's just move that a little bit over. That I want to measure, but of course I'm only measuring 15, and when I do, I get scores of that variable. But we'll still make the heading here. X to represent I'm getting scores from the, the group of students that I get, but those scores are coming from the values of the variable. So based on the 15 that I get, the range of values seem to be 0 to 9. 0 to 9. Let me just adjust my screen here. Side. So I'm not sure if that is the actual range. If I surveyed absolutely every person, but based on this, 0 to 9 seems to be the values of x. 0, 1, 2, 3, 4. Can't skip any value in that range that I observe. Then I want to get the frequency of how many times these values occur as scores in my collection of 15 measurements. So I see here 0, I get 1, 2, 3, 4, 5 times. Now I won't bore you with every one of them. Can pause the video on this and see, can you complete the frequencies for the rest? And then we will finish the table and you can confirm your own calculations. So it's very important to, if you understand what we're doing, try it on your own. It has a lot of value in solidifying that understanding. So I'll give you a second. Feel free to pause here. Right? Maybe you've done that, maybe you haven't. The rest of the frequencies I'll just quickly do. I get a 1 twice, and a 2 twice, and a 1, and a 3 once. Same for 4, same for 5. I get a 6 twice, 7 0 times, 8 0 times, and a 9 once. So even though the 7, the 8 don't occur at all, I can't skip them or leave them out. It is important. Now I can certainly check and add these together to see if my frequencies add up to 15 as well. And at this stage, I just want to introduce our calculator, which hopefully will show on the screen. Let me just check one of my students. We sort of chat and communicate through Discord. My Discord server has a calculator built in called MathBot. Let's ask it what is 2 plus 3. See if it's awake. And it says 5. Good job, MathBot. Now I want to use this. This is my calculator. I can't really display a handheld calculator, right? So this is a way for you to see my calculations on screen, even though MathBot might sometimes show it in a weird way. I will add my frequencies, 5 plus 2. I am typing as I'm saying it, but you will only see the end result. Plus 2 plus 1 plus 1 plus 1, then a 2, and then last 1 there. I won't include the zeros. I get 15, which then tells me, oops, random line. Doesn't tell me it's perfectly correct, but if that is not a 15, oops, that was not 15, that then indicates that I missed something when I was trying to go back and forth and count. Especially when this gets long, it's easy to miss a little number. Adding up the frequencies and checking if you get what they say you should get helps a lot. Then you can do the fraction relative frequencies. You can do it in percentages. I'll emphasize this one and just show how we get the percentage. So it's out of 15, 5. Actually, let's side here. Just erase this line a little bit so I have space. Let's put this here. So the relative frequency for 0 is 5 out of 15, and then I'm going to multiply by 100. Let's see what MathBot says, though it's not a super hard calculation, but it's nice to display it so you have something to look at. It is, of course, 33.33%. Random lines are going to pop up all the time as I switch windows. See that? I'm just worried that the cat cam is in the way. No, the sleeping cat is not disturbing. Good. So that'll give us here our 33.33, and rounding to 2 decimal places will be perfectly fine for our purposes. Now again, this is a lot of the same calculation over and over and over. So feel free again to pause, get the most value out of this because we're only doing one by hand, and see if you can complete this relative frequency percentage column. Right? Maybe you paused, maybe you got some numbers. Let's see. For the next one, obviously 2 out of 15 percentage, that's 13.3%. The 2 is the same, so as soon as something repeats in terms of the frequency, then great, I don't have to do a brand new calculation. 1 frequency will be 6.67 when I round it to 2 decimal places. Same for this one. So it's certainly valuable. It has value to do your initial examples by hand, absolutely. But there's a lot of repetition and it can feel a little tedious very quickly. But don't dismiss this step. Whoops, that's a 6, 7. Dismiss it. I can now add these up and check that I get 100%, which means all my calculations were hopefully correct. I'll save that for you to do, but I do have another check here. So that's how we're going to do our frequency table. You can add columns there if you want, but these are the 3 most important columns. Then it's nice to see that graphically. Let's make a new page so I don't scroll up and down. That can level here. So now we want to draw our histogram. Histogram, not a bar graph because this is not a numerical variable. This is not a categorical variable. So, and it's not a rank variable either. It's an interval variable. I do have a 0, but I don't really care to distinguish ratio variable. It doesn't really matter for general uh, problems and our basic introduction level. All right, so I'm going to use straight line tool. Otherwise, these lines are going to get really wobbly really fast. So I want to make my vertical axis and my horizontal axis, and it's nice to label them. Vertical axis here, I'm going to go with relative frequency as a percentage. Why not? Just do the frequency as well, but the distribution shape is going to be the same. Here I have my specific X values. Now, some people get a little uncomfortable that 0 has to be on this vertical axis. No, not really, right? I like to have in the case of individual values, it should be the center of the bar that I draw. And I don't like to have my bar over and then get confused. What's this negative side? How can you fall in love negative times? So I like to give myself some space. So my bar is going to be centered here at 0 and spread them out sufficiently, maybe not that far, so that I can fit all 9 in. That 1, 2, 3, and doing this by hand, it is slow. It's always going to be the slowest version. And it's going to make me appreciate the more efficient methods. Not methods. I made them way too narrow, right? I had a lot more space. That's okay. That's okay. It's going to be clear enough. So my relative frequencies only go up to 33%, which is 5 out of 15, right? So I want 5 markings. Let's say over here is 5 out of 15. As tedious as it may seem, has value by hand. So I know this is 5 out of 15 or 33.3%. The others will be, I don't even have a 4 or a 3 out of 15. The 2 is 13.33%, which will sit over here. And this was 6.67%, right? That's, of course, my 0 line, which there are some. I can complete this if I want to. Sure, let's be nice and complete. But you don't have to label every single thing, especially if it's not there. It's clear what my scale is. But I would have to do 3 out of 15. Well, that's going to be 20%, isn't it? Let's double check. 20%. 4 out of 15. 4 out of 15. You can probably hear the keys in the background. As I'm typing some stuff, these random lines are going all the way as I'm switching windows. Sorry, that 6 got away from me there. Okay, now I want to take note of the height of the bars being the frequencies. So 5, I'm going to change to maybe like this, make a little bar. I have the highest bar, 33.33%. So that's going to sitting. Whoops, I had my tool ready. Where's my tool now? I had my rectangle tool changed his mind. The bar. Next one is going to be a 2, and actually 2 2s. It's this one over here, right? So I try and be as neat as I can. Definitely doing it by hand. The challenge is being neat. I want to go to the center here, and because I just eyeballed this, it's certainly not going to be exactly the same width, but they should be, and the same height there too, right? Then I have 3 1s for 3, 4, and 5. Get a 1. Everyone gets a 1 with us. Just try and make them the same height. So again, when I do it by hand, it doesn't have to be absolutely perfect, right? But it still has value. 6 has a frequency of 2, which is a relative. Do it from the bottom this time. See of 13% or so. Then 2 zeros, which is just a completely flat bar or space really. And at 9, I have a 6.67 again. So at 6.67. So especially because I have such a small collection of data values, or scores rather, to work from, gaps in my histogram can be quite common. So this is now trying to approximate the actual distribution of these values, what I could see among all college students. More of them will say low values, and it seems like fewer will have high values for this characteristic. So we can say it is positively skewed. And the way I remember it, the tail, as it goes long down towards the horizontal axis, the side that sits on, in this case the positive side, that is the term for the skewness. So this is a positively skewed distribution. Of course, the more college students I interview, the more accurate this would become in representing the actual underlying distribution. But we'll talk more about that in the topics as we go. So that was our example where we did the or practiced the concepts by way of go up here, hand calculation. Next up, we'll do a very similar question, but we'll see how we can use a spreadsheet to do that. I'll use Microsoft Excel, but you can certainly, I'll try and do it in a way that you can use other spreadsheet applications as well. But that will be our next video. See you then.